Hi and Assalamualaikum. I am Madam Shiva. We will discuss Chapter 7, Gravitation, under subtopic 7.3, Satellite Motion in the Circular Orbit. Okay, in this subtopic we have escape velocity of satellites, and the period of a satellite. Okay, we look at the first questions. Okay, JSAT 7A is a 2000 kilogram satellite that is seen stationary to an observer on the Earth. Okay, it is orbiting with a radius of 42,000 kilometers from the center of the Earth. Okay, given the mass of the Earth is a 6 times 10 to the power 24 kilogram. Radius of the Earth is 6.4 times 10 to the power 6 meter. And the mass of the Moon is a 7.35 times 10 to the power 22 kilogram. Okay, even though our situation is not involve the Moon, so you just give the mass of the Moon. Okay, one is name the type of motion for the satellite. Okay, so we know that the satellite will move around the Earth. So we have Earth here. Okay, and then the satellites at the certain altitude. Okay, now given the altitude is about the 42,000 kilometers from the center of the Earth. So the satellite will move around the Earth. Okay, this type of motion we call circular motion. So the answer for number 1 is circular motion. Okay. Okay, number 2, calculate the escape velocity of the satellite from the Earth's surface. Okay, so from the Earth's surface means our satellite now is at the surface of the Earth. Okay. Okay, so before that, we will define what is escape velocity. Escape velocity is defined as the minimum velocity required by a mass to escape completely from gravitational field to infinity in outer space. So, now the initial location of our satellite is at the surface of the Earth. Right? Okay. And then it will escape from the surface of the Earth to the infinity. Okay, so at infinity, the gravitational potential energy, okay, is equal to 0, and the kinetic energy is almost 0. Okay, now we will be using the concept of the conservation of energy. Okay, energy initial is equal to the dimension energy final. Okay, which is at the initial at the surface of the Earth. So it's a start to escape or start to moving. So we have a kinetic energy and also the gravitational energy. Potential energy. Okay, and then the kinetic energy is equal to half mv squared. And the mass is the mass for the satellite, not mass of the Earth, because the satellite will move out from the surface, not the Earth. Okay, and then the gravitational potential energy, the formula is a negative G m1, m2. So m is a mass for Earth and m2 is a mass for satellite. Okay, over the R. So the radius, the satellite to the center of the Earth. Okay, and at the final or at the infinity, the energy is equal to 0. So we arrange our equation here. So we get the velocity, the minimum velocity or the escape velocity here. Okay, v is equal to 2gm over r. Okay, square root 2gm over r. Okay, now we substitute the value here. Okay, 2 times the g is a gravitational constant, which is a 6.67 times 10 negative 11. And the mass of the Earth, because from the operation, we cancel out the mass of satellite. So now just left the mass of the Earth. 6 times 10 to the power 24. Okay. Over the R. R is the radius satellite to the center of the Earth. So means our question is satellite from the Earth's surface. So we just take the radius of the Earth. Okay. 6.4 times 10 to the power 6. Okay. We must square root all the value here. And we will get the answer is 11.18. Okay, and the unit for the velocity is the same with the velocity that you studied before this. Okay, meter per second. Okay, done for number 1. And this include the learning outcome for escape velocity. Okay, we will use, and how to derive the escape velocity, we will use the concept of conservation of energy here. Okay, now we will move to the second question. Okay, it's about speed and period. Okay, so the question is 1,000 kilogram satellite in an orbit 350 kilometer above the Earth. So now our satellite is about 350 kilometer. Okay, this altitude. Okay, and so how to calculate the speed of satellite? Okay, we take our Earth again. Okay, and then we have a satellite. We move around. Okay, around the Earth in the circular motion. So what type? The direction of speed is, the speed mean is a tangential lah. So when we take the root of the circular motion, it mean this angular velocity. Okay, so this our v. Okay, is changing to the point every point of the orbit. Okay, and then the type of force involved in this motion is gravitational force Fg, which is always direct to the center of the Earth. Okay, this is our center of the Earth. Okay. Okay, now how to calculate V here? So we use the concept of Newton's second law, which is the summation F is equal to ma, and a is involved in this motion is a centripetal acceleration. Okay, so mac is also is equal to centripetal force. Okay, so we arrange back our formula to mac. So now we want the speed. So the other formula for mac is mv squared over r. Okay, and what type of force involved in this motion is Fg. Okay, so Fg is equal to G m1 m2 over r squared. Okay, the mv squared over r, mass here is a mass for the satellite. Okay, let's say the mass satellite is m1. Okay, the satellite is m1 and the mass of the Earth is m2. Okay, so from here, okay, we arrange back our formula, blah, 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 blah. Okay, we will get the velocity is equal to gm over, okay, slightly same with the escape velocity, okay, without 2. Okay, and then I think you must try it to derive this formula. Okay, and then we will get v equal to square root gm over r. Okay, now we substitute the value here for the speed ni. Okay, the g is a 6.67 times 10 negative 11, and the mass of the Earth m2 is 6 times 10 to the power 24. Don't worry. So all the constant will be given. Okay, and the radius of the satellite. Okay, we must include the altitude because it's a move in the orbit is about 350 kilometers from above the Earth. So we must plus with the radius of the Earth because the concept R here is from satellite to the center of the Earth. Okay, so radius of the Earth is 6.4 times 10 to the power 6. Okay, and plus with the altitude 350 kilometer. So times dengan 10 to the power of 3, you will convert to meter. Okay, square root, and then use your calculator, you will get the answer is about 7.69 times 10 to the power of 3 meter per second. Okay, done for number 1. Okay. Okay, now for the period. Okay, we use the concept of velocity here. Okay, v. This is for number 2. Okay, v. Okay, the formula for v for the circular motion, v is equal to omega. Okay, please revise this formula in the chapter 6. Okay, v equal to the omega r. Okay, and the omega is the angular velocity is equal to 2 pi over t. That's why we will get the period from the 2 pi over t here. Okay, so now the V is equal to omega R, and also is equal to, okay, we take this formula, okay, square root GM over R, okay. So omega is a 2 pi over T times R is equal to square root GM over R, okay, and then we will arrange back our equation here. We will get T is equal to R cube. Oh, sorry, not R cube, directly cube. So don't forget your 2 pi here. Okay, R cube over GM and square root. Okay. Alright. Okay. So as usual, okay, we substitute the value here. R. Okay, don't forget R. Okay, the radius of the Earth 6.4 times 10 to the power 6 plus 350 kilometer here. Okay, times 3. Okay, and don't forget to power of 3 because it is our formula. Okay, over G is a gravitational constant. 6.67 times 10 negative 11. And the mass of Earth 10 times 10 to the power 24. Okay, don't forget to square root again. And you will get 5.51 times 10 to the power 3 seconds. So if we convert to minutes, okay, 5.51 to the power of 3, okay, divide by 60, you will get in minutes. And time by 60 again to get the hour. So it's about 1.53 hour. Okay, hours. Okay, that's for failure. So the satellite takes 1.53 hours to complete one revolution around the Earth. So you could imagine how many times is revolve the Earth in one day. Okay, one day we have 24 hours. So that's the number of revolution that satellite makes to orbiting the Earth, within one day. Okay, now for the third one. Okay, so we take this space for number 3. Okay, the radial acceleration of the satellite. Okay, so we take the formula AC here. Okay, AC, centripetal acceleration. Okay, actually, the radial acceleration is also equal to the centripetal acceleration because AC and radial acceleration is a direction is always toward to center. Okay, so AC is equal to V squared over R. Okay, and then so we take the value of V here. Okay, 7.69 times 10 to the power of 3. Okay, over don't forget to square. And over R. R is again, okay, 6.4 times 10 to the power 6, that is of Earth, plus with the altitude 350 kilometer. Okay, so you will get the value is about, okay, blah 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 blah. Okay, don't forget to use your calculator. You will get the 10.55 meter per second squared. Don't forget the unit for the acceleration is a meter per second squared. Okay, done for number 2. Okay, so refer to our learning outcome. So we have our escape velocity. Okay, and then we're using the conservation of energy. Now we calculate the speed. Okay, using the Newton's second law and using the formula for the velocity. So we derive it to find the formula for the period of the satellite, and then now we will get the radial acceleration. Okay, now we move to the question number 3. Okay, question number 3 is included in your tutorial. Okay, I forgot which number is it. Okay, so it's also is a past questions 2014-2015. Okay, we look at the last question here. Okay, number 3. Okay, a 120 kilogram satellite is orbiting the Earth at the altitude of 190 kilometer. Okay, now our satellite is at 190 kilometer. Okay, the radius and the mass of the Earth are 6.4 times 10 to the power 6 meter. And the method is about, okay, they given the 5.98 times 10 to the power 24 kilogram respectively. Okay, even though in the question, given the constant, the value of the mass of the Earth, radius of the Earth, okay, and then in the question, again, they given the value of the radius of the Earth and the mass, okay, we use the value at the question, yeah. Okay, calculate the first one, this we revise subtopic 7.2. Okay, gravitational potential energy of the satellite. Okay, and then number 2, period of the satellite, and then the change in speed of the satellite for break free for the orbit. Okay, we look at the gravitational potential energy of the satellite. So with that, we sketch the Earth and the satellite. Okay, this orbiting around the Earth. Okay, the altitude is about 190 kilometer. Okay, so how to calculate the gravitational potential here? So we came up our formula for the gravitational potential energy. What is the formula? U is equal to, don't forget your negative, okay, G M1 M2 over R. Okay, just substitute the value for the gravitational constant. Don't forget the value of negative, means the potential is at the infinity, so means is the direction is away from the Earth. Okay, G is a 6.67 times 10 negative 11. Okay, the mass of Earth. Okay, we using the 598. Okay, 5.98 times 10 to the power 24. And the mass of satellite given by 120 kilogram. Okay, over the R. R is the location of a satellite to the center of the Earth. So the altitude plus dengan the radius of the Earth. Okay, radius of the Earth given by 6.4 times 10 to the power of 6. Okay, plus with the its altitude is 190 kilometers. So the 190 times 10 to the power of 3. Okay, so the final answer we will get the negative 7.29 times 10 negative 9. And but the unit for the energy is a joule. Okay, done. Okay, now we look at the number 2. Okay, number 2 is a period of satellite. So we directly use the formula period. Okay, no need to derive because the second question we have a derive the formula. So now we use the formula T is equal to 2 pi R cube over GM, okay, square root. Okay, 2 pi, and the R is, okay, again we use the center of the Earth. Okay, the radius of the Earth from the center. Okay, 6.4 times 10 to the power 6 plus the altitude is 190 times 10 to the power of 3. Okay, don't forget to power of 3. Okay, over G. G is a 6.67 times 10 negative 11. Okay, and don't worry if you do your question again and again. So the constant G is always in your mind. Okay, 6.67 times 10 negative 11, and the mass of the Earth given by 5.98 times 10 to the power 24. Okay, so okay, sorry. We arrange back our equation here, formula. Okay, so this with square root and then times 2 pi. Okay, so from that value, we get the 5313.36 seconds, and is equal to, okay, we when calculate back the time here, we will get it's about 1.47 hours. Okay, it's logic, yeah, because it's just 190 kilometer. Okay, it's not take too long to satellite to orbit around the Earth. Yeah. Okay, so now the third one. The third is a change in the change in speed of the satellite for it break free from the orbit. So for this, means is the difference value for the velocity of the satellite and the escape velocity. Okay, for number 3, okay, for the change in speeds means the delta V is equal to V escape minus dengan the V or the speed of the satellite. Okay, so how many velocity to take? Not how many velocity. What is the difference of the speed to make the satellite move around the Earth and the speed to escape the satellite from the path. So that's why the delta, the change in speed for the satellite for the break free is mean the delta V. So V escape minus V. So this level is C4. Okay, this when analyze this question. Okay, more. So this not included in our formula. So you just list down this formula we will get mark. Okay, so we start to calculate here. Okay, delta V is equal to, okay, firstly we find the escape velocity first. Okay, the formula is a 2gm over r square root. Okay, so 2 times 6.67 times 10 negative 11, and the mass of the Earth is 5.98 times 10 negative 24. Okay, over the radius. Okay, the radius is, don't forget to include 190 kilometer here. Okay, 6.4 times 10 power 6 plus with 190 times 10 the power of 3. Okay, don't forget to square root here. And then you will get the answer. It's about 11.02 times 10 the power 3 meter per second. Okay, and then for the speed for the satellite, okay, the formula is a gm over r square root. Okay, so you will get that. Okay, I will direct okay lah, 6.67 times 10 negative 11, and the mass of the Earth is 5.98 times 10 negative 4 over dengan 6.4 times 10 the power 6 plus with the altitude 190 kilometer. Okay, don't forget to square root. So the speed is about 7.79 times 10 power 3 meter per second. Okay, look at it. Okay, the escape velocity is higher than the speed of velocity. So the change in speed, okay, so means when it move more than 11.02, so the satellite will the out from the root. Okay, so delta V is a V escape to minus with the speed of a satellite. So 11.02 times 10 to the power of 3 minus with 7.78 times 10 to the power 3. So the difference of the speed is about 3.22 times 10 to the power of 3 meter per second. So the speed of the satellite is about 7.78 times 10 to the power 3 or 7,000 meter per second. Okay, when it increase by 11.02, okay, so the satellite will move out from the root. Okay, so that's all for the question for the chapter 7, okay, under subtopic 7.3. Okay, I hope you enjoy the question and the solutions. Okay, bye.